Hello, beautifuls. This is Atleen, and I'm coming to you with another video. And today, we will continue to discuss virtual server. This is going to be the next topic, which is also pieces and parts that make up the network, which is virtualization. I'm going to start off with basically just telling you what we're going to do today. I'll be doing a reading, and then we're going to do I know this already? But there will be a part two of virtualization fundamentals, virtual machines, and I'll do a few things on the whiteboard. So virtualization has drastically changed the world over the past 10 years or so. So when it comes to networking, um, for example, it's good when you work for an organization, say a campus, it's good to avoid wasting resources such as power resources and, keeping all the servers up to date. Like, say a college of finance may only be using 4% of hard drive capacity, which is basically um, an example of having a dedicated server for each college. So it's pretty great. It's a great thing that we can now have a powerful server with lots of resources that can virtualize all of those individual servers that can be used to be on their own box. We can, basically instead put them in a virtual machine and run them on one physical box. And doing this will give a corporation great cost savings, which is what we need, which is good for a corporation. We'll go more into that tomorrow. Today, we're going to be discussing virtualization fundamentals in chapter 15, and is underneath cloud architecture and network fundamentals. And we're going with the book today is volume 2, CCNA 200-301. And of course, it's Wendell Odom. Okay, so I will read. Cloud computing, or cloud, is an approach as to how to offer services to customers. For IT service to be considered to be a cloud computing, it should have these characteristics. It can be requested on demand. It can dynamically scale, that is, it is elastic. It uses a pool of resources. It has a variety of network access options, and it can be measured and billed back to the user based on the amount used. Cloud computing relies on data centers that can be automated. For instance, to service request, cloud computing system will create virtual server instances, virtual machines, also known as VMs. If you can see that, let me just make sure I get it focused. And configure the settings on each VM to provide requested service. Now with the server virtualization foundation topics, when you think of a server, what comes to mind? Is it a desktop computer with a fast CPU? A desktop computer with lots of RAM? Is it hardware that would not sit upright on the floor but could be easily bolted into a rack in data center? When you think of a server, do you not even think of hardware, but of the server operating system, the OS, running somewhere as a virtual machine? Virtual machine. All those answers are accurate from one perspective or another, but in most every other discussion within the scope of CCNA certification, We ignore those details. From the perspective of most CCNA discussions, a server is a place to run applications with users connecting to those applications over the network. The book then represents the server with an icon that looks like a desktop computer. That is the standard Cisco icon for a server. This next topic breaks down some different perspectives on what it means to be a server and prepares us to then discuss cloud computing. So we'll be discussing virtualization first, and then we'll go into cloud computing a little bit later. Think about the form factor of servers for a moment. That is the shape and size of the physical server. If you were to build a server on your own, what would it look like? How big, how wide, how tall, and so on. Even if you have never seen a device characterized as a server, consider these key facts. No KVM. For most servers, there is no permanent user who sits near the server. All the users and administrators connect to the server over the network. As a result, there is no need for a permanent keyboard, video display, or mouse, collectively referred to as KVM. Racks of servers in a data center. In the early years of servers, a server was any computer with relatively fast CPU, large amounts of RAM, and so on. Today, companies put many servers into one room, a data center, and one goal is to not waste space. So, making servers with a form factor that fits in a standard rack makes for efficient use of the available space, especially when you do not expect people to be sitting in front of each other, of each server. And this is an example of a Cisco USC server, B series blade. So since we got the basics of that read, we're going to go into the server virtualization basics. This is what we're discussing today. Server virtualization basics. Okay, so think of a server, the hardware, as one computer. It can be one of the blades in figure 15-1. A powerful computer you can buy at a local computer store, whatever. That's what it says, whatever. Traditionally, when you think of one server, that one server runs one OS. Inside the hardware includes CPU, some RAM, some kind of permanent storage like disk drives, and one or more NICs. And that one OS, NICs, network interface card, and that one OS can use all the hardware inside the server and then run one or more applications. 15-2 shows those main ideas. Storage, CPU, RAM, and the network. Physical server model, physical hardware, one OS, and applications. Today, With most companies instead create a virtualized data center. And that means the company purchases server hardware, installs it in racks, and then treats all the CPU, RAM, and so on as capacity in the data center. Then each OS instance is decoupled from the hardware and is therefore virtual in contrast to physical. Each piece of hardware that we would formerly have thought of as a server runs multiple instances of an OS at the same time, and each virtual OS instant called a virtual machine or VM. And I'm emphasizing virtual machines because that's our topic for tonight. And it's not traditional. In the last decade, a lot of things have changed to virtual machines. A single physical host server often has more processing power than you need for one OS. Thinking about processors for a moment, modern server CPUs have multiple cores, processors in a single CPU chip. Each core may be able to run multiple threads with a feature called multi-threading. So when you read about a particular Intel processor with 8 cores and multi-threading, typically 2 threads per core, that one CPU chip can execute 16 different programs concurrently. The hypervisor, and we'll talk about that tomorrow, introduced shortly. I will go over it tomorrow and put a few things on a whiteboard for more of a visual. Can then treat each available thread as a virtual CPU, vCPU, and give each VM a number of vCPUs. With 16 available in this example, a VM that is an OS instance that is decoupled from server hardware still must execute on hardware. So at any one point in time, each VM is running on a physical server using a subset of the CPU, RAM, storage, and NICs on the server, as shown here in 15-3. Four VMs running on one host. Hypervisor manages the hardware. You can see that. These are the virtual machines above. And subset of CPU, RAM network. To make server virtualization work, each physical server, called a host, in the server virtualization world uses a hypervisor, and we'll go over that more so tomorrow on the whiteboard. The hypervisor manages and allocates the host hardware, CPU, RAM, etc., to each VM based on the settings for the VM. So we're gonna stop right here, and I'm gonna go back to do I know this already? Because that can possibly be on the CCNA exam. 3, okay, it's 1 through 6. 1 through 6. And the one that discusses the virtual machine is 1 and 2. So 1 states 3 virtual machines, if you can see that, okay. 3 virtual machines run on one physical server. Which one of the following server Which of the following server resources sources are commonly virtualized so each VM can use the required amount of that resource? And it was three, right? NIC, RAM, CPU. All right. Thank you for watching. Thank you for subscribing. Thank you for listening. And I'll see you tomorrow. It's going to be a part 2 of virtualization. We went over a little bit of 15 minutes. We don't want it to be too long. So I wish you well.